So the factors that play a role in our hearing. Number one is nature has given us 2 ears. And there is a very specific reason why we have 2 ears. And the reason is the location of where a sound is coming from. Every human is inherently capable of locating danger, whether it's coming from the right or to the left. You don't actually have to see it. It's because we have 2 ears. And there is a very, very specific reason. So in 1876, Riley said, and he did a lot of experimentation on it, and he said that low frequency sounds, think of it as men's voices, were more difficult to locate rather than high-pitched sounds. Do you remember when we were talking about diffraction, we said men's voices diffracted more? But he said that low-pitched sounds, because of that, also make it very difficult to locate exactly where they're coming from. So think of these at the top picture as your low-pitched sounds. This is the sound shadow that they create. So it's kind of hard for you to locate exactly where they're coming from. But with a high-pitched sound that comes in, you know exactly where this is coming from. Whereas for this one, it's kind of hard to tell, right? Because they're low-pitched. They will cause a shadow with your ear. Whereas this one, pretty much this entire thing will be a shadow. And your ear will not be able, this ear will not hear much. This ear will have the most impact of them, right? So he said that low frequency sounds were more difficult than high frequency ones. Which leads us to why we need 2 ears. For sounds less than 1.5 kilohertz, the location of the sound is found by the difference in arrival time between the 2 ears. For sounds greater than 1.5 kilohertz, basically high-pitched sounds, it's located by the difference between the ears. And I'll give you a formula for that. So think about it this way. This sound versus this sound. Which has a longer path, 1 or 2? 2 has a longer path, right? So did we do speed equals distance over time? So the speed did not change, but the distance did. So that means the time also has to change to keep the speed the same. Because the actual physical path changed. And this is the formula. If this is L1 and this is L2, since the speed cannot change, the time delay is delta T equals L2 minus L1 divided by V. And note, V is the speed of sound at the particular temperature that we are looking at. Remember, sound depends on temperature. As temperature goes up, does the speed of sound go up or down? Goes up. Very good. So in a normal room, having 2 ears is essential to understand speech and to counteract the natural echoes that occur in a closed space. So binaural hearing, hearing with 2 ears, is way better than hearing with 1 ear because it increases the signal loudness, where the sound is coming from, localization, also speech legibility, and it improves sound quality. Number 2, spatial hearing or localization. Humans and other animals with 2 ears can localize the sound, especially localize them when multiple sounds reach our ear. How do we do that? When sounds reach our ear, they will always either interfere constructively or destructively. From, if let's say the amplitude of is A and the other one amplitude is A, they will have all the ranges from 0 to 2A. Depending on that, you can pretty much localize what kind of sound is coming towards you and where is it coming from. So how do we tell? We tell where the sound is coming from by which side it reached us first. And we know of this phenomenon from when we were very, very little, all the way until we're very old. We just don't realize it, that that's what's happening. So every human head is a sound, I don't want to say absorber, but stopper, right? Just like it will create, like it'll stop the sound from going through. So if you, okay, I want you to do something. I want you to snap your fingers if you can. Hold them towards your right. Close your eyes. Okay, now, if you can, close your right ear with your other hand and do the same. What do you observe? Did it go that low? But did anything happen to your left ear? Like, did you hear the same amount from your left ear? Now try that again. Hold like this, but close the other ear. Did it make you feel weird? Did it give you like an echo, weird echo? Because you're not used to not using both ears. But when you were doing this, the sound didn't change much because you were expecting, your brain was expecting to hear from here. But now try that again. We're going to try this again. We're going to close our ears. This one, the one closer to the one where we're trying this. Then we're going to try it again with our left, closing our left ear. It just makes me feel panicked when I close this ear. I don't know if it's the same for you guys, but try it when you go out. For me, I always feel more panicked if I can't hear from both of my ears, but I feel less panicked. Maybe it's just me. I don't know. We should test this, but I feel more panicked when I cannot hear from the side that's further away. But that may just be me. That may not be general. But we should test that with a bunch of people to see if they all feel the way I do. But there's a reason for it, is because our head is a shadow. And when I close this ear, my brain is expecting sound to come from here, but it's not. I want to try one thing. So everybody close your eyes, no cheating. And I'm going to snap my fingers and you're going to tell me where I am. Okay, no cheating, no looking up. Point to where you think I am. Okay, everybody open your eyes. Look at where you're pointing. Is that true? Okay, now do it again. Everybody pointing? Good. Open. Is that true? Good. And it becomes very difficult to locate where a person is. That's why we need 2 ears to tell where the sound is coming from, right? Okay, so having said that, that in scientific terms is called an acoustic shadow. That shadow that our skull creates is called an acoustic shadow.